We're going to finish up section 1.2 angle relationships by working two quick examples illustrating how these relationships can be used to solve different unknown measures. We want to find 1, 2, 3, and 4 in the given figure, knowing that M and N are parallel. Start with what you know. Angle 1 and angle 2 both have measures associated with them, and notice that they are alternate. That is, that they are on opposite sides of the transversal, and they're exterior angles. So alternate exterior angles have equal measures. Therefore, we can set 3x plus 2 degrees equivalent to 5x minus 40 degrees. Now I'm going to use a little bit of algebra and solve this problem for the variable x. Subtracting 3x from both sides of the equation, I would end up with 2x on the right-hand side. Adding 40 to both sides of the equation, I would end up with 42 on the left-hand side. And finally, dividing through by 2, x would be 21. Now, what I have discovered is the value for x, but it has not answered the question as to the measures of the angles. So I'm going to go back and find those one by one. Angle 1 measured 3x plus 2 degrees. So now I know that x is actually 21, and I can find the measure of angle 1. Angle 1 is going to be 3 times 21 is 63, plus 2 would be 65 degrees. Do not forget your degree symbol. That's very important right now. Okay, we know angle 1, and so since angle 1 and angle 4 are equivalent by the idea of alternate exterior angles, we have that angle 4 is also 65 degrees. Very quick find on that one. Similarly, notice that angle 1 and angle 3 are vertical angles. And we know from our rules about angle relationships that vertical angles also equal. So angle 3 is 65 degrees too. All right, that leaves us one angle to find. I'm going to note that angle 1 and angle 2 form a straight angle or a straight line. Therefore, the measure of angle 1 plus the measure of angle 2 should add up to 180 degrees, which means angle 2 should measure the 180 degrees minus whatever angle 1 is, and we know that's 65 degrees. So angle 2 should measure 115 degrees. And we've located all 4 angle measurements just by using our rules that we learned about angle relationships. Example 2 will be a little bit more in depth, but we will make it just fine. I will be a little bit all over the page just because it's hard to structure it, but try to follow me as I'm speaking and writing, and you should be okay. I'm going to start in this upper left-hand corner over here, and I'm going to compare angle 8 and 120 degrees, and note that they are forming a straight line. So angle 8 and the 120 degree angle that is beside it form a straight angle, which means they should equal to 180 degrees. Solving that particular problem for angle 8, I would have 180 minus 120, so angle 8 would be 60 degrees. I'm going to just erase that black line, and I'm going to label angle 8 as 60 degrees. Now, angle 8 and angle 5 are corresponding angles, and so they have an equal measure as well, which means I already know that angle 5 is 60 degrees because of that corresponding relationship. Similarly, angle 5 and angle 3 are vertical angles, and by definition of vertical angles, they have equal measure. So angle 3 is also 60 degrees. So this one's 60 and this one's 60. Now as I look at the bottom section, which is where I'm focusing at the moment, I have an angle that I know measures 55 degrees, and angle 1 is vertical to that. So angle 1 is going to be 55 degrees because it is a vertical set of angles. So on the bottom, I can finish that up if I just knew angle 2 or angle 4. I'm going to look at this as an entire section, and thus I would see that angle 1 plus angle 2 plus angle 3 make that straight angle or that straight line and would equal to 180 degrees. Angle 2 is what I'm solving for, so it would be 180 degrees minus angle 1, which we already found to be 50 degrees, minus angle 3, which we already found to be 60 degrees. And angle 2, if I'm doing this in my head correctly, should be 65 degrees. Okay. I'm going to extend my page. That's going to zoom us out a little bit. Hopefully you can still see what's going on. Angle 2 is equivalent to angle 4 because they are vertical angles. So angle 4 is 65 degrees. Back to the top portion of our figure. Angle 8 and angle 7 are vertical. Therefore, angle 7 should be 60 degrees. Angle 6 is vertical to 120 degrees. So angle 6 is equal to 100 degrees because it is a vertical angle. And I'm going to erase this one more time just so we can measure and compare. Angle 1 and angle 10 are corresponding. Therefore, angle 10 is the same measure as angle 1, and angle 1 we already know is 55 degrees. And angle 10 and angle 9 are corresponding. So angle 9 is also 50 degrees because it is vertical to angle 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of our angles have been found, maybe not in the most of conventional ways, but they've been found, and hopefully that has given you a great illustration of how to use these angle relationship properties.